Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is IGCSE Physics Paper 4. And this is a theory paper, and this physics is the standard physics. The code for this subject is 0625, and this paper is 4-1, May, June 2023. And today we have selected question number 10 of this paper. And this paper, why I'm doing the question number 10, I'm preparing this question for my O-levels students because this question is related with the space physics. And because in Cambridge O-level physics, we do not have that much questions on the space physics, but in IGCSE, we have the questions on the space physics. So that's why I am attempting this question. So this is 062541 May, June 2023, question number 10. So let's start. So the question number 10 of this paper is showing up on your screen. It says the Pluto is a dwarf planet. Figure 10.1 shows the direction of motion of the Pluto as it follows its elliptical orbit around the sun. So this is the orbit of the Pluto, and it's elliptical. It's not circular, it's elliptical. And the sun is here, and you can see during this, when the Pluto is moving in this orbit, it comes near the sun and then it goes away from the sun. So here we have position X, which is near the sun. Here we have position Y, which is at a very far distance from the sun. So direction of the motion is this. This is, you can say, it's moving in anti-clockwise direction. And he says the point X is the point on the orbit closest to the sun, and the point Y is the point furthest away. The orbital speed of the Pluto varies as it orbits the sun. Describe how the speed of the Pluto varies as it moves from X to Y and then back to X. Okay, so when the Pluto is nearest to the sun, the its speed is maximum. And when the Pluto is furthest at point Y, I mean, its speed is slowest. So when it is going from X to Y, the speed of the Pluto decreases. And when the Pluto is going from Y to X, the speed of the Pluto increases. Because at the point X, when it is near the sun, the speed is very high. And when it is at point Y, is furthest from the sun, the speed is slow. So as you go from X to Y, speed will decrease from Y to X. When it will come from Y to X, the speed will increase. So let me show you my written answer. As the Pluto moves from the X to Y, its speed decreases. And when the Pluto moves from Y to X, its speed increases. That's the simple answer. And so you can see the marking scheme also. This is that question. And okay, question number 10, part A, and its second portion. Explain in terms of energy transfers why the speed of the Pluto varies in this way. It's a 3 marks question. So try to understand this question. Okay, so at X, the Pluto will have maximum kinetic energy. And as it moves away from the sun, the gravitational potential energy of the Pluto increases. So at point Y, it will have maximum gravitational potential energy. And at point X, it will have maximum kinetic energy. So as it moves from X to Y, its kinetic energy converts into the gravitational potential energy. And when it moves from Y to X, its gravitational potential energy converts into the kinetic energy. During this, the total energy of the Pluto remains constant. So that's why the energy is converting from the kinetic energy to the gravitational potential energy. And when it is going from X to Y, when it's coming from Y to X, the gravitational potential energy converts into the kinetic energy. And the total energy of that system remains constant. This is our let me show you the answer. Question number 10A, second part. I've tried to wrote the answer. When Pluto moves from X to Y, its kinetic energy converts into the gravitational potential energy. And as it moves from Y to X, its gravitational potential energy converts into kinetic energy. Total energy remains constant. This is the reason at X speed is higher and at Y speed of Pluto is lower. The total energy of the system remains constant. So this is our answer. So let's have a look at the marking scheme. Here you can see the marking scheme is also showing up. And if you want to take time, you can pause the video and you can take your time with this marking scheme. Okay, so let's go to the next part. He says, this is question number 10 and its B part is first portion. The average temperature on the surface of the Pluto is 43 Kelvin. And convert this temperature to a value in degrees Celsius. You remember that conversion, the K is equals to 273 plus C. That is the famous formula. So the C will be equals to K minus 273. Now the temperature is 43 Kelvin. In degrees Celsius, it will be 43 minus 273, and it will be minus 230. It will be minus 230. So I forgot to write here a negative sign. Minus 230 degrees Celsius. Minus 230 degrees Celsius is the right answer, sir. And this is my solution. Hopefully you understand. So question number 10, it's B part, it's second portion. Pluto has a white surface as shown in the figure 10.2. So this surface is basically white on the Pluto. Figure 10.2, as Pluto rotates, the white surface alternately faces towards and away from the sun. Explain how this affects the temperature of the Pluto as it rotates on its own axis. So they are talking about the Pluto rotating on its own axis, like the Earth rotates on its own axis. And because this white surface, its color is white, the white is a bad absorber of the infrared radiation. But a white color is also a bad, you can say, emitter of the infrared radiation also. So it's a bad absorber of the infrared rays, and it's a bad emitter of the infrared rays. So what happens when the white surface will face, when the white surface will face the sun, the temperature rise will be less because it's a poor absorber of the infrared rays. And when the white surface will be away from the sun, it's a bad emitter of infrared rays. So the temperature drop will be also a very small temperature drop because it's a bad emitter of the infrared rays. So overall, the variation in the temperature when it's facing the sun and it's away from the sun, that white surface, that will be very small. So the variation in the temperature when it's facing and when it's facing away from the sun, that will be very small. Let me show you my written answer. So here we go. You can see white surfaces are poor absorber of infrared rays. It is also poor emitter of infrared rays. When white surface face sun, rise of temperature is small. When white surface face away from sun, drop in temperature is also small. So the variation in temperature is small. On the other hand, if you talk about this black surface, on the other hand, the black surface will be a very good absorber and a very good emitter of the infrared rays. So on the black surface, when the black surface will be facing the sun, its temperature rise will be more, and when it will be facing away, its temperature drop will be higher. So this is the marking scheme is showing up on your screen, and so you see, you can pause the video, you can take your time with this marking scheme. So hopefully you understand this. This is question number 10 from this paper. And you know why we are doing this? Because we are preparing the topic space physics for O-levels physics paper. And so I hope you understand this question. If you find this question interesting, my video interesting and useful, please share the link of this video with your friends and with your class fellows. And I think it's a great blessing for me that I can make these videos and help so many students around the globe. So thank you very much. Have a good day. God bless you all.